Okay, so section 12.1, exploring solids. This is where we finally move on to three-dimensional figures instead of two-dimensional shapes and lines and points and all those kinds of things. So this is a little bit different video, and I'm trying it out, and hopefully it'll work. Now let's see here. First of all, the following are polyhedron solids. So instead of calling them three-dimensional stuff and things, let's actually figure out how to name them. All right. What must be true about a polyhedron solid? Well, a polyhedron solid must have bases that are polygons. Must have bases that are polygons. If I don't have that, I don't have a polyhedron. Okay, now let's look here. The bases of this thing here, in fact this thing is called a prism, these are rectangles. Okay, so this is a prism with rectangular bases, so it's a rectangular prism. Okay? It's a prism because it has two polygonal bases. Two bases that are polygons. That's what makes it a prism. This over here to the right is a pyramid. And we look at the base. The base is a hexagon. It is then a hexagonal pyramid. We'll be dealing a lot with pyramids and polygons. That is a hexagonal pyramid. The following are non-polyhedra. Non-polyhedra solids. The first one here is a cone. This number 2 is a half cylinder. This is a sphere. But we're not really worried about naming those yet. We just need to know that these do not have polygon bases. Okay, do not have polygon bases. Alright, let's get some vocab down. Polyhedron, we just named it. We got it good up there. Okay? Faces. A face is the polygons that enclose a polyhedron. Polygons that enclose a polyhedron. An edge is anywhere two faces meet. So an edge is where two faces meet. There's an edge. Okay, let's draw a line in here. And a vertex, this is where two edges meet. Okay, an edge is where a vertex is where two edges meet. So if I look at my picture over here, I've got a couple things. I've got here in the front in blue, this is a base, but it's also, this is a face. Okay, this segment back here that's 10 units, this would be an edge. And this point here would be a vertex. Okay, so that's some vocab for you for the beginning of chapter 12. Let's move down to this stuff at the bottom here, okay? And I'm going to try and move my sheet of paper just straight up so that we can see what the heck's going on here. Good, okay. Alright, so in this example here, number 3, we want to determine, is it a polyhedron? How many faces, vertices, and edges does it have? And we want to name it, okay? Well, let's look. If I want to look at how many faces it has, it looks like I've got the base here. I don't want to highlight too much, but I've got the front base and the back of it. So that's 2. And then I've got this one that's kind of looks like a rectangle here on top. That's 3. I've got the bottom where it's sitting. That's 4. And then I've got this side over here to the left. That's 5. So it looks like I've got 5 faces. Okay. Let's look at how many vertices I have. It looks like I have 1, 2, 3, 4, 5, 6 vertices. Okay, so 6 vertices. And how many edges? It looks like I've got 1, 2, 3 on the front here. 1, 2, 3 in the back face there. And 1, 2, 3 there, so it looks like I've got 9 edges. How would I name this? Well, it has 2 triangles for bases, so it would be a triangular prism. Be a triangular prism. And that's it for that one. So we've pretty much answered everything. Now, let's go over to Euler's theorem. That's not Euler, it's Euler's theorem, all right? And his theorem says this: F plus V minus E equals 2. And F is faces, V is vertices, and E is edges. Okay, so if I look at my example here, I've got a hexagonal prism, right? And if we figured this out, it looks like I've got 1, 2, 3, 4, 5, 6 faces. So 6 plus how many vertices? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 plus 12 minus how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, minus 18. Oh, did I miss a couple? How many faces? 6, 7. Oh, I'm sorry, there's 8 faces. Jeez, oh, Pete, I forgot the bases. Okay. So, sorry, there's 8 plus 12, so, right, because you got to count the bases. So, 8 faces plus 12 minus 18, and that equals 2. Okay, so that's Euler's theorem. And if we were missing one of those, if I said, hey, it's got this many faces, this many vertices, how many edges does it have? You'd be able to solve that and figure that out. Okay? Let's move over here to regular polyhedron. Regular polyhedron means all the sides, all the faces are regular polygons. There's only 5 of them. Okay? There's the one with triangles, the one with squares, the one with another one with triangles, excuse me. It's kind of like doubling this this triangular pyramid up here. And then we've got one with pentagons, and then one with triangles that's even more complex. The names of these are not particularly important. Obviously, this is a cube, this is a triangular pyramid, but you don't really have to know the names. It's a kind of a neat thing. There's only 5, so it's worth mentioning. All right, let's talk about cross sections now. Let's see if maybe I can zoom here. Oh, yeah, okay. A cross section is whatever I imagine taking a plane and slicing it through a solid. So if I've got a cube here and I slice that plane, take a plane and slice it through the solid, I want to know what shape it creates. So what I'm really looking at here is this outline in the center of the cube right here. And this, if I could kind of take it out and draw it, would be, assuming it's a cube, it would be a perfect square. Okay, it looks like a cube, so we'll go with that. It's a square. All right, that's that cross section, or that slice down the middle of the square. Okay, that would be, or the cube. Okay, move over here. Describe the cross section of this one. Well, this one, my plane here, that's kind of lighter, is hitting this cube at an angle. So it changes the cross section. The cross section now looks like this. And I would say that that is going to be a trapezoid. Okay, looks like a trapezoid. That would be the cross section of that. The cross section of this cone over here, obviously, it's pretty clear, is going to be a circle. Okay, and that's really it for chapter 12. You're going to use that Euler's theorem quite a bit. We're going to be naming polygons, but overall I think this will be a good section for a good, nice, quick section. It shouldn't take you too long to do on your homework. And that's it.